Hi everyone, my name is Anam Naveed and I'm a software engineer on the PowerShell team.
And my name's Amber Erickson, and I'm also a software engineer on the PowerShell team.
Today we're going to talk about PowerShellGet, some of its historical changes, challenges, and new features. But first, let's talk about what PowerShellGet is. PowerShellGet is the package manager for PowerShell. It's a module that lets you find, install, update, and publish packages to or from a repository store. Now, by default, PowerShellGet will consume packages from the PowerShell Gallery repository store, which is maintained by our team, but it can easily support other repository stores as well. These repository stores can be local or remote. A local repository store is one whose location is file share based, such as in the picture on the left, where I have a repository store named testlocal, and as you can see, its URL location is a path on my file system. A remote repository store, on the other hand, is one that's hosted online, such as in the picture on the right.
And if you're unfamiliar, PowerShellGet started off as a package provider for package management, so the two have always been inextricably linked together. You can see here that package management provides core functionality for generic packages, and it comes with a submodule called the NuGet provider, which is pretty self-explanatory, a provider for NuGet-based packages. And PowerShellGet is essentially another package provider built on top of that. The fundamental premise was that it would act as a wrapper for package management, extending the functionality of the NuGet provider, since PowerShell modules are NuGet-based packages, while also providing some more nuance, specifically for handling PowerShell modules and scripts. However, the generic package provider model that package management embodied didn't really gain adoption, and package management itself is now primarily used for PowerShellGet. And as you can see with this diagram, the flow of a PowerShellGet commandlet is pretty convoluted. With PowerShellGet 2.2.5 and below, a commandlet such as find module would start off in PowerShellGet, then need to go through package management, then the NuGet provider, then to some private functions in PowerShellGet, then back to the NuGet provider, and then back to the calling public function in PowerShellGet. The back and forth between the NuGet provider and the private PowerShellGet functions can happen a number of times, and because the two are separate repositories and one is written in PowerShell and the other C#, it makes stepping through a debug scenario a huge headache. Not to mention, oftentimes a bug in one repo would also require an update in the other. So one of the most important high-level changes that we wanted to address with the rewrite of PowerShellGet is removing package management from the equation completely. Another thing you'll notice here is a dependency on the NuGet or .NET executable. And this dependency occurs because the NuGet provider doesn't have any publish functionality. So on top of bootstrapping the NuGet provider, one of these executables needs to be bootstrapped as well. And as many people have commented on in the past, this can be a frustrating experience, especially if working with an offline machine. So the goal is to deprecate a clunky and cumbersome package management and have a more streamlined and easy to maintain repo for PowerShellGet that's easier to contribute to and easier to build out. So again, part of this means only having one repo, and another part of it is only using one language, C#, which allows us to have more control in terms of integration, general performance improvements, and use of libraries. And specifically, moving to C# has allowed us to extend NuGet client APIs and gain some functionality that had previously been lacking in PowerShellGet. But you can see in this diagram that the architecture of PowerShellGet is now much more streamlined, much easier to trace, and again, will be significantly easier to maintain and to contribute to.
So as Amber just mentioned, by rewriting PowerShellGet in C#, we're able to extend NuGet functionality by using the NuGet client APIs. Let's look at this relationship specifically. The NuGet APIs we use for PowerShellGet are client-side APIs that interact with the server-side APIs. They are used to download packages, fetch package metadata, publish packages, and much more. When we rewrote PowerShellGet, we decided to use the NuGet client APIs because they're easy to leverage, extensible, and provide a smooth transition with future changes. By using the NuGet client APIs, we don't need to do the heavy lifting that comes with directly interacting with the server-side APIs, such as having to write our own implementation for the client side. Instead, we get to leverage NuGet's client-side formatting of objects, query structures, access to important metadata, and other aspects afforded by their APIs, so we can easily extend them for our own use cases. The NuGet APIs also support interacting with v2 and v3 protocols that package sources may be using. They support almost all cases for v2 and v3 protocols, except for wildcard search, but more on this later. Also, if major changes come up in the future, such as a new protocol or modifications to the server-side APIs, the NuGet team would update their client-side APIs and the changes would trickle down to us. Now, Amber is going to dive into some of the differences between v2 and v3 protocols the NuGet APIs support.
So one exciting new feature with PowerShellGet v3 is that it'll be able to interact with the NuGet v3 server protocol. And that's great because we'll gain a bunch of performance benefits. And I've highlighted a couple of quotes, the first of which is from the NuGet team itself, and they say that from our Visual Studio NuGet package restore duration, we see that v3 is about 19% faster on average than v2. The median duration is only marginally better in v3, but customers with less ideal network conditions have a much better experience on v3. And the second from the Nexus Repository Manager states that the Nexus product team testing for performance of NuGet v3 over v2 shows 25 to 50% faster build times and about a 50% reduction in their memory usage. So there's significant advantages in moving to a protocol that's newer and more thoughtfully designed. A few years back, the NuGet team created the v3 server protocol in order to better handle the growth and amount of traffic the NuGet gallery was receiving. They are orders of magnitude larger than the PowerShell gallery, so we never really had to move on to the v3 protocol. That said, we've seen a vast amount of growth on the PowerShell gallery and do anticipate that sooner or later it'll be necessary to move on to an updated protocol that can handle these larger loads more efficiently. And right now, we do have future plans that are just in the initial stages to adopt NuGet server-side functionality that will enable us to essentially inherit newer protocols. And again, we care about adopting v3, but by extending both client-side and server-side NuGet APIs, we can position ourselves in such a way that we can easily adopt any future protocols they create as well. And so to go into a deeper dive about the differences between the two protocols, the v2 protocol is XML-based and is structured around OData queries. There are package entities, and each package is represented by an entry element. So this entry contains the metadata associated with the package that the client would then retrieve as appropriate. Our v2 protocol uses Lucene indexing to pre-process the tables in our database to be optimized for searching. And our search queries themselves use an OData structure. And the URL would look something like this. So we have PowerShellGallery.com with the specific endpoint of v2. And then we have the v3 protocol. And the v3 protocol is JSON-based. The landing page for the v3 protocol, which would be the package source or the URL that the client is trying to connect to, is called the service index. And so here we have an example using the NuGet gallery. And you can see the basic JSON format right here. And the URL would look something like this. And so we have NuGet.org with the specific endpoint of v3/index.json. And this is a JSON document that contains a list of resources which provide different functionality and satisfy different use cases for the site. And you can see in this example that we have resources such as the search query service, which filter and search for packages by keyword, which you would imagine is a crucial component for the site. And to dive into this resource specifically, the search query service is an API that allows queries for a page of packages that match a specific search query. And how the search query behaves, that is how the search terms are tokenized, is determined by the server implementation. But the general expectation is that a search query is used for matching package names, versions, descriptions, and tags. However, it's not necessarily exclusive to those particular package properties. So for V3, instead of using Lucene indexing and OData, all the querying and indexing is done through Azure Cognitive Search, formerly known as Azure Search. And another important resource, which is actually not mandatory to implement, as this chart states, is the catalog. And the catalog is an append-only API that allows a user to see the recorded history of all of the packages that have been added, modified, or deleted from the repository. And a key difference between the V2 and V3 protocols is that in V2, enumerating through all packages on a repository is as simple as running the OData query, PowerShellGallery.com/API/V2/packages. But in order to do that in V3, you need to implement a catalog reader. And I'm mentioning this because an important component of searching in PowerShellGet includes searches that require iterating through all packages in a repository. An obvious scenario would be simply a search to find all packages. For example, find PS resource -name star. And you may want to use a command like this to replicate an entire repository, for example, to create a mirror, or you might use it to detect when new package versions have been released, or to find packages that depend on a package that you've published, etc. But we actually also need to enumerate through all packages for any sort of wildcard use. For example, find PS resource -name power star or star get or p star t. And the legacy way of doing this typically depended on sorting the OData package entity by timestamp and then paging across the massive results using the skip and top parameters. And this approach had a number of drawbacks, one of which was potentially accidentally skipping packages because the queries for V2 are made on data that is often in changing order. Another is the slow query response time, which has to do with the fact that the queries are very basic and just not optimized for performance. Yet another is the inability to have a query reproduce results in the exact same order consistently. And so the V3 way of doing this now requires a catalog reader. And this is actually something that we had to implement in PowerShellGet V3 because the NuGet client APIs don't support wildcard searches. And Enum has done some really excellent work in folding that into PowerShellGet so that we can make sure that we fully support that scenario in both the V2 and V3 protocols. And I'll hand it over to Enum to talk more about the catalog reader and her work with implementing wildcard searches.
Thanks, Amber. So as Amber just explained, the NuGet client APIs we use provide client-side support for both V2 and V3 protocols in most cases, except for that of searching with wildcards. Now, to be clear, the NuGet API for searching can actually handle wildcards, but it doesn't exactly line up with our expected behavior. Instead, it appears to do wildcard matching without start and end anchors. So if you look at the picture on the right, if I search for PStarShell using the NuGet API, it performs matching without start and end anchors, which means that our search term doesn't have boundaries, and a string that has text before the P or after the shell in our PStarShell pattern will also be counted as a match. We don't want that though. A second issue is that the API doesn't just match the name. If the description of the package or other metadata contains a match, it'll return that package too. These issues meant we needed to provide our own wildcard implementation or extend off the NuGet APIs to achieve our expected wildcard behavior. So given these challenges, how are we currently handling wildcards in V2 and V3? Well, for the V2 protocol, we implement wildcard search by using the NuGet V2 API that sends an OData query to the package source feed. We provide this query with the desired package name containing a wildcard. The NuGet API returns a small set of packages back from the server, which matched NuGet's wildcard behavior. So we filter further on these server results to get a subset of the packages which actually match our wildcard behavior. For the V3 protocol, we handle search a bit differently. We use the service index for the package source. And again, that's just the landing page for the source feed that has links to all resources available. If the name of the package we wish to search for does not contain wildcards, we simply use a NuGet V3 API to search from the feed by package name. This API doesn't support wildcards though. So if instead we had a name with wildcards, we first check if the service index document contains a catalog resource. The catalog resource essentially contains a recorded history of all packages that have been added, deleted, or modified in the package source feed. So it can be used to get all the packages from that package source. We use this to get all the packages and then filter upon those to get only the packages whose name matched our wildcard pattern. So overall, the v3 protocol allows you to directly interact with the package source feed and perform your usual core functionality. But it's also extendable and lets us work with an optional catalog for faster searches. Before I discuss the wildcard implementation, I'm going to quickly describe how the catalog reader resource works. Let's say I wanted to access a package from the NuGet gallery package source that has a v3 protocol endpoint. To connect to the package feed, I first need its service index. Again, the service index is just the landing page document for the package source, which contains a list of available resources. From this document, I can find the URL to the catalog resource, called the catalog index if it's been listed. So I use the catalog index to reach the catalog resource. Again, the catalog resource is just a document containing a chronological listing of pages. And each page contains a group of catalog items that were recorded between certain timestamps. And each catalog item represents the package's state at a single point in time, and whether the package was being created, unlisted, relisted, or deleted from the package source. Since each item has a unique timestamp and items are recorded chronologically, we can actually index through the entire catalog and process it in chronological order to create a mirror of the whole package source. The client will use a cursor locally to keep track of up to what point in time they had processed catalog items. This lets you index through catalog items quickly and to search for packages between the cursor timestamp and current timestamp to see if any new catalog items have been posted. While the v3 search process we just saw is more complicated than v2, it leads to faster searches, especially for package sources that are orders of magnitude larger than PowerShell Gallery. And fortunately for us, the NuGet CatalogReader library provides APIs to search through a v3 endpoint repository store without having to worry about these inner workings of the catalog. Let's look at a demo for this. So over here, we're going to first check which repository stores we have registered by running the get ps resource repository commandlet. And we can see we have the NuGet gallery repository registered and its URL has a v3 endpoint. Next, we're going to run the command to find packages from this repository store by doing find ps resource -name, and the name is going to contain a wildcard. We're going to specify that we want to search from the NuGet gallery repository. So now the search begins from this v3 endpoint repository store. And this will take a little bit of time. But as you can see, the update progress bar is being shown and the search is wrapping up here. And as we'll see in a second, the repositories that get returned match our wildcard pattern name that we specified. So while we were able to add this new functionality, we still ran into a few challenges. Firstly, if the repository store is large, then retrieving all the packages is slightly time-consuming. Since the API returns an read-only list, the entire read operation happens at once. So we're not able to stream and provide progress updates during then to improve the user experience. One solution we have in mind for this is implementing a local cache, which we plan to do by our vNext milestone. Secondly, in implementing the wildcard search for v3 protocols, we realized that not every package source feed may have a catalog resource, as the catalog resource is optional. So in the case where a user wishes to find a package with a wildcard name from a v3 endpoint repository store that doesn't implement the catalog resource, our solution is to just modify the v3 endpoint to its v2 alternative endpoint and perform the search that way.
Thanks, Sanam. That was a great demo. I just wanted to spend a few minutes to talk about the roadmap of PowerShellGet. So we're currently working on getting a solid preview release into PowerShell, and then our GA after that, which is on the horizon. And that'll include basic parity with PowerShellGet v2, supporting v3 protocol endpoints, better repository management, better NuGet integration, but most importantly, just a more streamlined experience all around. We want the commandlets to be easier and more intuitive to use, meaning you don't constantly hit errors or warnings or prompts or need to run commands a second time to add a force parameter, unless it's absolutely necessary. And for our next couple of releases after our GA, we plan to implement features such as the local cache that Anum had mentioned. And then we also plan to expand our NuGet integration and plan on implementing credential persistence, most likely with secret management. And then even further down the road, we are planning on implementing features such as fuzzy results if resources are not found, and integrating with other popular online repositories. And so starting in May, we're going to be accepting community code contributions. Feel free to contribute any of your ideas by opening up an issue. You can also contribute by putting in PRs for bug fixes or new features. We always want to hear what works for you or what doesn't work and any ways that we can improve your experience and make things smoother for you. So our GitHub is PowerShell/PowerShellGet, and you can reach out to us on there. You can also reach out to us individually via Twitter or GitHub, and we look forward from hearing from you all. Thank you all so much, and please try out PowerShellGet v3.